let's give this a try. So let's try sample problem number 1. And this is from lesson 11.4. Okay. Alrighty, should be good. Okay, so it says a technician is checking the circuits on a vehicle. The technician measures the current entering a component as that 0.47 amps. The potential is 12 volts. What is the resistance used grasp to solve this problem? So let's start off with our G. What is given to us? Well, we are given the potential difference, which is the voltage. So that is equal to 12 volts. And then we have the current of 0.47 amps. And that's it because we're looking for the resistance. So that's our G, which is our given. Our R is the requirement, and maybe a bit confusing, but this is also an R. We're looking for the resistance. So that is the R. For the A, I'm going to put it over on this side, we have to analyze. So let's take a look at doing some algebra quick. Why don't we start with the form V equals I times R for this equation. I picked one randomly. Let's rearrange this using some algebra to get it so that we can solve for R using V and I. So to rearrange this algebraically, we need R to be isolated by itself. So we have to move this I over to the left, where we have to move it over to with the V. So the question we ask ourselves, I and R, what is occurring there? We see that the operation is multiplication. Oops, as I shake my thing. The operation is multiplication. So what that means is I need to do the opposite of that, which is division, in order to isolate my variable. So I divide both sides by the letter I. On the right-hand side, I can see that since the I is in both numerator and denominator, it cancels out. And then my next line of the equation is going to be V over I equals R. And if I just flip it, which is the exact same thing, R equals V over I. And this is going to be the form of the equation that I will use for the A, for the analysis. Just wanted to show you some algebra there. So now the S, for the solve part, we can plug in. Resistance is equal to what? V over I. Always start with the sort of skeleton or blank equation, and then we can just do equal signs. The voltage was 12, current 0.47 amps, and then we can do our stuff there. Here's my calculator. 12 divided by 0.47 equals all those numbers there. Let's include just a couple of decimal places. 12.5319, let's just include a bunch. And don't forget the units of ohms. So I have all these decimal places in my answer, which I don't need. So let's talk about rounding. Like I mentioned, there's 2 decimal places here, so let's just keep that to 2 decimal places. I'm not going to worry too much about the rounding unless the question specifically asks you to round it to a certain value. This question doesn't mention to round to anything, so let's just keep it with some of the values we have in the question. So let's say we have 2 decimal places in one of our known given variables. So let's keep our 2 decimal places maybe in our answer, just arbitrarily. So 12.5, and then we have to ask ourselves what we're going to do with the 3, because that's what we're going to try and round. So whatever number I'm rounding, I look to the right, and I use this number as my guide. If this number here is below 5, I don't change this number. 1 is below 5, therefore the 3 stays the same. If this number here were bigger than 5, then I would round that 3 up, but I don't need to do that. And I have to include my units of ohms, and that's that. And then for the P, the paraphrase, the resistance is 12.53 ohms. And that's how we answer that question, using a bit more, just showing you how I'm writing it out with my terrible handwriting here. So hopefully this is helpful, and I can do more examples like this if you need it.